Hi, this is Michael. I'm back to talk about physics. Physics discussed for just anyone. I'm going to try to illustrate things with some basic things around your house to make it real plain and simple for us to have a discussion about theoretical physics. This particular series will be on the subject of how to explain what light is, the very nature of light. So, before I go too far, I do want to say this. Some of the things I'm going to discuss are controversial. They're really on the edge of what we can know. So, especially when we start talking about subatomic particles. So, when we get down into the quantum layer, there's so many ongoing arguments, so many ongoing experiments that to know exactly what's happening at this layer really forces us to try to compare our common knowledge with something that so far has defied common knowledge. But before I go too far, I do want to try to say that I'm going to attempt in every way I can to look at theories of physics that I think makes physics more accessible and argues for more common sense. And I'm definitely a person who believes in determinism. So, another thing about me is I'm not one of these atheist, scientific kind of guys. No. I believe the universe that we exist in was engineered by an alien intelligence. And most people refer to that alien intelligence as God. I do believe in the idea that there are multiple universes. But with that in mind, universes of different age, universes of different dimensions, that gives rise to a universal God. A God that is capable of controlling the creation of universes. That is what I believe has engineered our universe to very specific properties that enable our existence. The concept of a cosmic constant, that the vacuum of space, the pressure of that vacuum has to be at a very specific property that is so unique and couldn't be any different than it is by a number that is, has 32 zeros in it. In other words, it's a big number. The chances that our universe exists in the way it's configured is basically impossible that it could just happen. I mean, the chances are like somebody winning the lottery 100 times in a row. Wow, we're lucky, aren't we? I think most people think that's called being impossible. And even if it was possible, intelligent, sapient entities are more probable to come into existence on their own than our universe. So there is a theory called the Boltzmann mind. The idea that you could actually arrange atoms randomly in such a way that it would bring forth logical gates and perception just randomly. And the odds of that happening are far less than the odds of our universe existing in the way it is. So, with that in mind, I believe you can understand the nature of everything in the universe because it was engineered. It wasn't just thrown together like just throwing dirt up in the air and expecting it to land and it be a house just because you threw some dirt up in the air. Anyway, let's talk about light. And I'm going to talk about light using a bowl of oranges. That's right, a bowl of oranges. You might say, what has a bowl of oranges got to do with photons? Well, I'm going to introduce you to a new concept. And this concept is called photon orbits. I think anybody who's listening to this video at all, you probably have some idea of the structure of an atom, the idea of quarks, the idea of strong force, weak force. Maybe that's a little different. But you do understand the concept that the electron finds itself in a shell, which often is called an orbit, but it's nothing like an orbit. The Earth goes around the sun, that's an orbit, but we stay on the same plane when we go around the sun. The electrons, they go all over the place. And they're more like ripples or waves than they are like particles, but there's a particle aspect to electrons. But for the most part, they look like, it looks like there's a little, you can almost think of the nuclear of an atom as being surrounded by force fields, like the Star Trek Enterprise. It has its force fields around it. And the nuclear of the atom has this force field, and there's multiple ones of them. And in that force field, there's this little ripple that happens that we call an electron. It's almost like as if this field has a place in it that randomly pulsates with a wave, and it's like a localized dense location inside this field. A sudden density happens inside the field that produces an electron. True, you could describe an electron as a wave, but we also know that it's definitely a particle because we can shoot them at things. You know, and you can, that's what your TV used to do with a little electron gun in the back, a vacuum tube, and it used to shoot the screen with an electron. And they would control where that little electron would go. It's a physical particle at that point. You can treat it both mathematically. I'm going to say they are both, but they're both in a different way than we normally think, and I'm going to explain that by talking about what makes light and what light is. And I'm going to start off with this bowl. And I'm going to say that bowl is an electron. And I'm, again, going to introduce you to a concept that you've never heard before. I don't believe anyone's ever brought this up. I've never heard of anyone discuss it, nor has it ever been put into literature before that I know of. And that is the idea that photon particles can be in orbit around the electron. Did you hear that? I'll let that settle in a bit. Photons are particles that orbit electrons. They do not hit the electron, they orbit the electron, and as they orbit the electron, they give their energy to the electron and can, at that point, because of this orbit, throw the electron into a higher location in orbit around the nucleus of an atom. So electrons can be pushed into a higher orbit because a photon comes and goes around it, giving it additional momentum because of the added momentum produced by the new gravitational effect. It pulls it out. Well, not gravitational effect, just the attraction, the forces between, which I haven't even come up with. I'm sorry, I said gravitational effect. That's ridiculous. There's an attraction between the photon and the electron that keeps it in orbit. That force, which I haven't even thought of a name for, is what, when it goes into orbit, gives rise to pulling the electron into a higher orbit. That's something that plays well with how we see light. When we look at light, we know it's produced by the change in orbit of an electron. So when an electron drops in orbit, so it's going around a nucleus like this, and imagine I'm the nucleus and it's going around me. If it drops down closer to me in orbit, it will give off energy in the form of a photon. That photon will fly off, and depending on the distance that the electron moved, the photon will have with it a certain wavelength. So, what I would argue is something based on pilot waves theory that would say that the reason why the photon flew off in the first place was because of the momentum and the pilot wave that's produced by the electron. That the electron vibrates at different frequencies, producing certain waves, and that these waves act like a kind of, in a way, a synchronization with the photon that's going around the electron. But if it moves into a different orbit, of course the speed changes. You know, its movement around is going to be at a different speed now. I mean, it's going around the nucleus now a lot faster. since it's now going around faster, you know, it's completing an orbit quicker, it has a different kind of wave pattern it produces, which is no longer in sync with the photon. And the photon flies off because of the difference in the way this wave pattern is. It causes basically the wave to push the orange out. So I'm just introduced another concept. Again, remember, I'm deterministic. I believe everything can be explained. And so when you hear that light is both a wave and it's a particle, both at the same time in some mysterious, mystic way, I say, no, it's not that mysterious, and it isn't like that at all. It is not complicated, it's simple. Light is both a wave and a particle at the same time because both things are happening at the same time. You have a wave created by the electron that synchronizes with the photon. And when that wave is changed suddenly by something in the way the electron is moving around the nucleus, it causes a pulse wave that can push against the photon. It's like it becomes an interference wave that has momentum, and it gives momentum to the particle. So the particle rides the wave. You get it? They both are there. There's a particle and there is a wave. They exist at the same exact time, like a surfboard on a wave. And so again, electron moves around the orbit. It does so at a certain speed. It produces waves as it's doing that. I can't explain what those waves are in. I'm not there yet. I'm just going to say, theoretically, there are waves produced by the electron and also by the photon. They kind of get entangled together in an orbit-like entanglement. If suddenly the electron changes orbit, it also changes its speed around the nucleus, changing the wave pattern it was producing, which now interferes with the photon and actually pushes the photon out. And that interference moves at the speed of light. So light is a wave and a particle at the same time. But it also orbits an electron because of it can become in sync with an electron pilot wave, get caught in it, in the patterns of this pilot wave. It gets caught in it and it can be thrown out by it. Anyway, that's my explanation for what a photon is. It's my explanation for what light is. It's also really cool if we could detect pilot waves. The implications of us being able to detect pilot waves, though, is if quantum mechanics is correct and you really can entangle things, then at a distance, you know, that's spooky interaction at a distance. That is something that means that pilot waves are leaking out all the time. Meaning you should be able to pick up these pilot waves at a distance, a long distance. Meaning data that's moving around on our networks, data that's moving around on devices, it's all basically bleeding out there into space in little waves that are below our current specs for our machines, because our machines work at the electron level. We don't have essentially photon machines yet that use photons instead of electrons to measure things. What we typically have is an electron gun. What we would need is to be able to create devices out of photons so that you can actually start to control measurements at the size and dimension of a photon, which is unbelievably small, but would allow you to start looking at measuring out things as interesting as a pilot wave, because pilot waves are smaller than photons. But at least you could potentially use photons to measure them. But we just don't have devices that work quite that way yet. Get there. More like there are giant apparatuses than they are devices. We would need to be able to create photon transistors. Anyway, thanks for listening. Have a good day. Bye.